Hi there, it's Dr. Embody with a video to get you started on Project 6. Sorry it's a little late, had some problems yesterday. So let's dive into this. So what we're trying to do here is crack zip files, or password protected zip files. And the basic idea is we're just going to try a password, see if it opens it. And if it doesn't, an error is generated. So we use the try except and capture that. So we just loop, just get a password, which is a string. So we get a string, try that as a password, see if it raises an error. If it doesn't raise an error, then it opened it successfully, and we print out the password that we found. We're going to have two approaches to doing this. One is a brute force. Try all the passwords. By the way, start small, work up to larger. We do give you a maximum, but it's always better to start small. So start with passwords of length 1, and then passwords of length 2, and then passwords of length 3. Try all combinations. And it's just that's called brute force. Just try them all. Just take a string, see if it unzips the file. If it doesn't generate an error, it did. If it generates an error, then nope, I guess we'll go and try another one. So you put that in the loop, and boom, 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 just try all the possibilities. Dictionary one is kind of similar in the sense that we're just trying possibilities. So we grabbed a real password file, and you really ought to take a look at it to see the stupid things that people use for passwords. Things like 1, 2, 3, 4, 5, 6. Oh, let's be really clever. 1, 2, 3, 4, 5, 6, 7, and or maybe the word password. So we take this file, and you've read through files of words before, so you just loop through the file, take that string, try it as a password, and again, if it succeeds, boom. Otherwise, it generates an error, and then we just grab another string off the file. By the way, make sure you strip it, right? And so that's what we're going to try and do. And we got two possibilities. We prompt for it. Here's give me a zip file, give me a dictionary, try everything in the dictionary. So with that, what are the tools that we have? Well, we've got a lot of tools. We import some modules. So there's one for somebody to unzip files. So let's use the zip file one. And we use that to open the file, and then to see if we can extract things out of the zip file. And it's the extraction part that has the password. So we do that, and then the other is we generate. How do you generate all the possibilities? An A, a B, a C, and then AA, AB, AC, AD, and so on. Well, there's this thing called iter tools, and that lets us generate all those possibilities. So we're going to use that too. And what I'd like to show you here is how some of those pieces work. Because this is really putting pieces together. The project in the end is not all that long. Oh yeah, there's some control stuff. You got to prompt for things, and you got to do you open the dictionary before you open the zip file? And we specify things like that. If you're going to do both of them, do you do the dictionary first? Do you do the dictionary second? And that type of thing. So you got to watch out for the things we specify in this before we give you some test cases. So let's take a look. All right, let's go down and take a look at some of the requirements here. Okay, so open a dictionary file. That's just like every other ones we've done. We've done a million of those. The zip file will be a little bit different because it takes something out of the zip file for opening it. So that's why I have two different functions. And then the two that I mentioned, the brute force and the dictionary, try all the possibilities, and then the dictionary reads a dictionary file. And then be careful. We talk about the ordering, and that's important for testing, as you know by that time. And we're also going to ask you to time things. Now, one question might be when you look at the test cases. Your time is different from my time. Your time will always be different than my time. We're not going to grade on the value that you get for the time. This is just to help you understand the difference between doing a brute force attack and a dictionary attack. Oh, by the way, the file of passwords that we give you, it's got about 1 million passwords in it. In the world of passwords, that's pretty small. If you were truly doing an attack, you might have a petabyte of passwords. That is a huge file. But that's the only limit. That's for serious cracking. So to deal with the zip files, that's how you open the file. We use this zip file thing, and this is how you do the extraction, and that's where the password part is. And we do something that we never should do, is we have except without that doesn't have an error in there. That's bad form, but we have no choice in this case, because when we do the extract all, it generates a whole slew of weird errors. And so the only practical thing to do in this case is to do the bad thing, which is to not have something written there. It's just like, any rule is there's a time to break it. And then with the iterating, we use this thing called product. You just loop through with product and some string. We'll actually use all the ASCII characters. So, you'll use the string.ascii lowercase there. But for just this illustration, try it in the shell with that. And this says I'm generating passwords of 3 characters. So you loop through this, like you do an I there, and put that in, close this loop and an outer loop, and you generate all the passwords of length 1 and then all the passwords of length 2 and blah, blah, blah. You know how to do that part. And then we got this weird thing called join, which I explained there, so I'll leave that. And then also in terms of time. Okay, so we import yet another module, and you just call time. We use process time here. There's actually a number of different times we want to use that one. And so you call time, what's the time now? Call a function, what's the time afterwards? And then you just take the difference of those, right? The later time minus the earlier time. And we ask you to round it up and stuff like that. The time values by themselves don't mean anything. There's actually a little register inside the processor that just counts, and the time that we get back from this is some number of seconds. We tell you to round it to 4 places. So a couple of other things is, we got the grading rubric, pass test 1, pass test 2, pass test 3 and 4, pass test 5, and so on. And then we ask you a question about law that you got to put up there, and then you got to make sure you put times in there. In the outputs, notice that we ask you to print out the laws and the penalty. So I'm not going to print that because you got to go find that. And the same thing with the passwords, right? I don't actually print out the password because that's no fun. And as I mentioned before, the times, your times aren't going to be like my times, and we're not going to grade on that. When we're running it consistently on a system, then we'll have some things that we'll be looking for, but times will vary a lot. But you do notice things like this, that my dictionary happens faster than my brute force. That's partly because by happenstance of the passwords that we have. And test case 3 and 4 are just testing things like your error checking, and test case 4 just checks to see if just plain Q will quit it. And test case 5 is a little interesting, worth spending some time on. When you specify both, you're going to do the dictionary attack first. So you ask for the dictionary file, and here we use the short dictionary, and that's just rather than 1,000,000 words, it has, I don't know, I took the first 20, 100, I don't remember, but the password's not in there. I did that on purpose so that we could check this, because if the dictionary fails, then we want you to do the brute force. And so I use the dictionary with the brute force because we know that will fail. right? And if we had 1 million words that we tried here, this just takes too long. So short dictionary, not only is the password not in there, but it's short enough so we don't have to wait all day for it to try 1 million different possibilities. So dictionary attack fails. Took that long to fail. Notice how short that is because there's nothing there. And then the brute force actually comes up with the password, and it takes a little longer. And then we do both again, and this time we use the real dictionary and we use the dictionary attack file. And guess what? If you succeed and find the password when you're doing both, if you succeed with the dictionary, there's no reason to go on and do the brute force. So there's a little control stuff there that's part of that. So a couple of things that are worth illustrating here is okay, like this part with opening the files. So let me make sure I remember what the exact name is of the zip files. So to open it. Okay, so now we're going to try to extract it, and to extract it, you're going to put this in a loop, but how might it work? So let's pick a stupid password. Something like that. And what am I going to do? So I'm going to try to extract. So we take the file that we opened. Notice. All right, so whatever, all right, I've got that name is the same as the name that I opened with. Okay, and here, we can call the password whatever we want, but I'm using password here, and don't forget the dot encode, and also I gotta remember to put another parentheses there. Better fix that up. And if this succeeds, we print out the password. And if we're in a loop at that point, you probably want to break. Here is we do the bad thing of not having an error type in there, and here I'll just say print nope. And so I know that this is not the password is not 1 2 3 4 5 6. So when I exercise this, it what happens? We try to extract it. It generates an error. We skip that line, and we come down here, and I print the word nope, which is entirely what I expected because I know that that's not the password. So you have to put that inside of a loop, and and then you got to do you got to break, and you're not going to print nope every time, and so on. And so in the brute force case, you got to try all the possibilities. In the dictionary case, you just keep reading words out of your dictionary and trying them. And that's your basic thing. Try to extract it, and if it succeeds, you print it out, and then stop your loop there. Don't keep going. Good time to use a break. Once you got the password, we don't want to. We don't want to keep going. And then the other part of it is the iter tools, and I've already done the import, and so let's see what this looks like. So to break this down, we're using this the from iter tools. We got this product, So we're using product. We're going to have some string, and of course we're not going to just want A, B, C, D, E, F. You're going to have the whole alphabet in there, and string.ascii lowercase is a good one to do. And then repeat. Here I'm doing it for 3 times, but we're going to put this in a loop and within another loop and keep trying all the passwords of length 1 and length 2 and so on. You know how to do that. So what this does is this generates passwords, or it generates strings of 3 characters out of that, and you can see here, it does do repeating of characters. So when I originally wrote this, wrote the project up, I did permutations, which didn't do repeats. That was a stupid thing for me to do. So you can learn from my mistakes on that. So there's sort of generally how to work with this. Watch out for the control at the end, and it's kind of fun. You get to see so what are the passwords, and you also take a look. I think there's some funny cartoons in one of these things after you unzip it. So that gives you a start. Good luck.